Hi Year 11, this is a short video about titrations. I'm going to talk to you about how we measure concentrations in chemistry, look at the equation which links moles, volume and concentration, and then describe why and how we perform a titration. First of all, concentration is measured in moles per decimetre cubed, or sometimes grams per decimetre cubed. So what does that mean? Well, a 1 mole per decimetre cubed solution would have a mole of the substance, the compound, dissolved in a decimetre cubed. And a decimetre cubed is a litre, is equivalent of a litre or 1,000 centimetres cubed. So if we dissolve 2 moles of sodium chloride in 1,000 centimetres cubed or decimetre cubed, that solution will have a concentration of 2 moles per decimetre cubed. Now we want to convert that to grams per decimetre cubed. Then we say, well, we know that 2 moles of sodium chloride must have a mass of 117 grams. Remember, a mole is the relative formula mass in grams, so you work that out for sodium chloride and then double it, and that's 117. So our 2 mole solution would also have a concentration of 117 grams per decimetre cubed. There are a couple of examples here to have a look at. I suggest you pause the video for a minute and have a go at those, and then I'm going to go through them on the next slide. So pause now, have a go, and okay. So first one, we know the MR of sodium nitrate is 85, so we know that a 1 mole per decimetre cubed solution would have 85 grams dissolved in a decimetre cubed of water. Now we want a 0.5, so we want half that, so we'd dissolve 42.5 grams in a decimetre cubed. So that would also, if we're talking about grams per decimetre cubed, that would be a 42.5 grams per decimetre cubed solution, fairly obviously. For the second one, well, a 1 mole per decimetre cubed solution would have 160 grams dissolved in it. A 0.1, we divide that by 10, we just dissolve 16 grams. But if we only want to make up half a decimetre cube, so 500 centimetres, then we would dissolve 8 grams in 500 centimetres cubed. So I hope that's beginning to make some kind of sense. Okay, now this is the equation that links moles, volume and concentration. Your volume has to be in decimetre cubes, which doesn't always seem that obvious, but you must make sure it is. And if you like to use a triangle, then this is the triangle: moles on the top, volume and concentration at the bottom. And we'll use that equation at the end of our titration to work out the moles in our mean titer. Okay, so why do we do a titration? Well, we do a titration to find out the concentration of an unknown acid or alkali, and we do it by neutralising it with a known acid or alkali. The equipment we use is a burette. Obviously that has to be held in a clamp and a retort stand. A conical flask, which we put our unknown solution in. The burette has our known in. Also in the conical flask we have an indicator, and we usually pop it on a white tile. To measure out our set volume accurately, we use a pipette. So what are the stages? Well, let's say if we've got an unknown concentration of alkali, then first of all we fill our burette with an acid of known concentration. We then measure out a known volume of our alkali into our conical flask. We add our indicator, and then we add the acid slowly until the indicator changes colour. Now it's important to mix your solutions together after each addition just by swirling the conical flask, and we also put the flask on a white tile because it just makes it easier to see the colour change. Indicators that you could use are methyl orange or phenolphthalein. Methyl orange goes from orange to pink, and phenolphthalein goes from pink to colourless. You choose the appropriate one for your titration. Okay, so when you're doing a titration, you're going to have a table like this to fill in. You've got a column for your trial titration, and then however many repeats. Now the trial is it's just a very rough titration. You do it quite quickly. It gives you an idea of where the end point is. Okay, and you can see this table. We put the initial reading here and the final reading above. That just makes it easier to take them away. It's not essential, but it's quite helpful. So we can see here our trial came to about 23.4. So next time we're starting at 23.4. That's our initial reading, and then when we get close to 22, around that kind of, then we start adding our acid very slowly, so we get a very clear end point. Okay, and in this instance that came at 45.3, so we take that one away from that one, which gives us our titer. You then need to repeat your titration at least once to get hopefully another titer which is fairly close. Now you may have to do this 3 or 4 times to get them close, but hopefully you'll do it quite quickly. When you work out your average, then you tend not to use your trial, okay, unless your trial is also very close to these. Okay, so you pick out your closest two titers and then make an average, and that is what you use to work out the moles of your known solution. And then using that and equations, you can work out the moles of your unknown. We'll find out how to do that in the next video. Okay, thanks.